So hi guys, my name is Jerome Villarosa, and today I am going to explain all about the calculation for the true azimuth of Polaris and the gyro error updating variation for 2017 and calculating for its deviation. So the first thing that we're going to do is that we do have here our tables. um since we do have only two tables, but I haven't printed this yet, but I did find the values or numbers that I needed by just looking at this table. So we do have here our um nautical almanac for 2017, and then we do have our increments and correction table, and the last one is that we have our Polaris Polestar tables, which is on 2017. So on this activity, on the 1st of December 2017, we do have our local time, which is 5 hours and 21 minutes 10 seconds. So our position is in north 10 degrees 19.0 minutes west, and then our longitude, it's 123 degrees 53.0 minutes. So we took gyro bearing of Polaris and observed 359.0 degrees. At the time of observation, our gyro heading is 80 degrees true, or 80 degrees, and our magnetic heading is 079 degrees. So we do have to solve the following, which is the true azimuth of Polaris, gyro error update for variation for 2017, and variation to Cebu port, and also calculate the deviation. So for this deviation, we just have to simply use our magnetic heading, which is 079 degrees, and we have to find our we did already found and determine that our variation of this particular heading, which is our magnetic heading, is 003.3 degrees east. So first we have to find our local time, which is 05 hours and 21 minutes and 10 seconds. Since our zone difference is +8, so we just have to add it. So 13 hours and 21 minutes and 10 seconds on the 1st of December 2017. So here we do have the first day of December. So we just have to find it into our almanac table. So it's the 1st of December, and I already online it since it's 500 hours. So we do have 145 and 48. 145 and 14.8 minutes, and for 21 minutes and 10 seconds we do have our increments and corrections. So it's 21 minutes, so we have to find 10 seconds. So 10 seconds we do have here 10 seconds, and I already underlined it from Aris, since we're looking for the GHA of our Aris. So it's 5 degrees and 18.4. So we just have to calculate it, and we will get 150 degrees and 33.12 minutes. And we should just have to calculate it again by subtracting it to our longitude, which is in our given here, this one. So it's 123 degrees and 53.0 minutes. So we did get our LHA of Polaris of 26 degrees and 40.12 minutes. So after that, we do have to update our variation. So our variation for 2015 is 1 degrees and 48.0 minutes west 2015, and it's on 6.0 west. So what we're going to do is that we have to update our variation from 2015 to 2017. So 2015, since it is increasing by 6 minutes, so we'll just subtract or minus it, so that would accumulate 2 years. and then we will just minus it since it is increasing by 6 minutes west, and then we'll get 12 degrees or minutes west. And then we added it to our updated variation, or for the updated variation of 2015. So it's 1 degree and 48.0 minutes, and that one will get variation of 2 degrees west. Right after that, we have to use our Polaris pulsar table. So we do have our LHA of Polaris here for 26 degrees and 40.12 minutes, but here we do have our Polaris table here. So what I did is that I dig up into this LHA of Polaris, and I've chosen 140 to 149 since we do have a 146 degrees. And then we will just point it out up to the month, and then to the azimuth, or to the latitude. Since we are on the third row, and we do have our latitude for 10 degrees here. 10 degrees here. So 10 degrees. So since there's no 10 degrees, but as you can see, 0 degrees latitude and 20 degrees has just had the same values. So we'll just use 20. So we are on the third row, so it's the 359.3. So our true azimuth, it's 359.3 degrees, and then minus our gyro bearing, which is 359.0 or 359.3, and we will just minus it to our gyro error, which is 0.3 degrees least or lowest or low. After that, we do have our gyro course. So our gyro course, it's embedded that our gyro course, it's 080 degrees. So we put 080 degrees, and our true course is 077 degrees, since it is being used for our variation. And then our magnetic course is 079 degrees, our magnetic heading. So you just have to subtract it, and that will get magnetic error for like 2 minutes west, and then, or 2 degrees west, I think. And then our variation, we did get it already, and our deviation, it's 000 or 001, since it is just close enough. So we will just use for checking, it's TVMDC. So if it is in a reverse way, so it's can dead man vote twice. But for TVMDC, it's just like for you to familiarize it, you just have to memorize TVMDZ as TV makes dull children. TV makes dull children. So it's TVMDZ. So how did we get it? So we do have our true course, it's 077 degrees, and our variation, it's 002 degrees, and we just had added it, and we accumulate 079 degrees for our magnetic course, and then we added 001 for our deviation. So we did add it, and we get gyro course for, or course for 080 degrees true. So that's how I get the calculation of my gyro error by Polaris azimuth using the nautical almanac tables. So that's all for now. Thank you, and I do hope you are already understand what I'm saying, and you're enlightened by what I am saying. So thank you for watching.